Thank you for being here, everyone. My name's James, and I am a PhD student at Loughborough University. My That map is there just because the first question everyone asks about Loughborough is where is it? So it's right in the centre of the UK. I am doing my PhD on internet protocol research, and today I'm going to talk about the work I've done as part of one of the Pulse research fellowships. So I'm going to go through the goals of the project, a quick definition, and then look at the motivation, methodology, and some results that we've got so far. So in terms of the goals, one of the goals of the Internet Society is to achieve 50% local traffic in selected economies by 2025. This is quite an ambitious goal, and it's been set as part of the Internet Society's 50-50 vision, which starts with selected economies and then hopefully will move on to 50% local traffic globally. And in order to achieve this goal, one of the main things we need to focus on is measurement. Because if we can't measure how much traffic is local, we can't then see the progress that's been made and what progress needs to be made in order to achieve this 50-50 vision. So what is traffic locality? Well, if we take this basic example, where a user is trying to access a local government website, by which we mean a government website for the same country, you might think that the best path for the traffic to take is something like this. And that is often the case. And the key component here is this link in the middle. And because this traffic flow from the user to the website does not leave the country, we define this traffic as local. Conversely, if the path looked something like this, where the user's traffic traversed an international network, we would then define this traffic as external. Likewise, if the government website was hosted outside of the country, we would also say that this content is external to the user. So, why are we looking at traffic locality? Well, there's three main reasons: policy, performance, and persistence. And by persistence, I actually mean availability. However, persistence fit better with three Ps for an alliteration. So in terms of policy, we want to check whether we can comply with existing policy and how we can affect policy decisions in the future to achieve better traffic locality. In terms of performance benefits, well, traveling a shorter distance is faster, and it can also improve user experience by making connectivity cheaper. And in terms of persistence, if users are accessing fewer external networks, it means that there is a higher resilience because you don't have to rely on the network infrastructure in other countries. So how are we doing this? Well, in a very basic way, we take a list of popular websites, we determine whether they're stored on the cloud or on a private server, and then we determine the location of that hosting method in order to say this website is local or externally accessed. In slightly more detail, we get a list of the most popular websites per country from the Google Chrome report. We then remove any censored websites. We then determine where the website is hosted by doing up to 3 lookups per domain. And finally, we geolocate either, as I said, the cloud provider or the privately hosted domain itself. And this is the step why removing censored websites is important. As you see here, we use residential proxies, and the details of that isn't particularly important in this amount of time. However, this uses devices in the country, and so we want to be able to remove the censored websites so the people that own the devices don't have their traffic all accessing censored websites that could potentially get them into trouble. So now we've got our methodology sorted. There are some limitations that we need to talk about before we look at the results. The first one is that websites are very complex. So there are many levels to a lot of websites, and there's a lot of embedded content as well. As it stands currently, we only look at the domain name itself. We don't do any additional scraping to check content that's within a website. We're also limited by the locations of the proxy probes. So if there are no good testing locations in a country, that makes our lives more challenging because we can't access the data as though we were in that country. which gives us better results. And then finally, we've got what we're calling the fog of cloud. And this just means if a website is hosted on a cloud provider, once we've reached that cloud provider, we don't know exactly where that data is coming from. So just because the user accesses a cloud provider within their country, that data could actually be stored halfway around the world and transported through the cloud. And there's no way for us to know with the current testing that we have. However, we could overcome these issues with different proxy providers by scraping the website in more detail. And then also the cloud issue can be overcome with things like latency testing so that we can measure round trip times to verify the locations we've got. So what have we done to improve this methodology? One of the big things we've worked on is changing the hosting platform identification. So there are existing platform identification tools such as Pythia and FindCDN. And these times that I've got here show how long it would take to get results for about 40,000 domains of testing domains on the internet. So through our work, we've managed to reduce this time down to 12 minutes and also maintain about a 95% accuracy compared to the other two tools, which is, we think, at least a very impressive reduction, especially given that the accuracy still remains high. So what do the results look like? Well, here's a global heat map to show the locality as of June this year across the world. There's no, I don't think anyway, there's any massive surprises. You're looking at places like Australia and the USA with very high locality. And if we just break it down by region, we see that Asia and Europe are the most local areas, regions, followed by the Americas, Oceania, and then Africa with a lower content locality. So as well as looking at per region, we can look at some more specific results as well. And we can also look at different things such as how many websites of the top 1,000 most popular are hosted on content providers versus hosted privately. And as we can see, it's about a 50-50 split across the world as it stands currently. We can also look at which CDNs are most local. So here we can see that Akamai and Facebook have a very high percentage of local websites they host, followed then by Cloudflare in third. But conversely, if we look at which CDNs are most popular, Cloudflare massively dominates in this space. And I should say as well that the amount of all other CDNs combined is around the same as Cloudflare. So there's a lot of different CDNs available, and Cloudflare is very much dominating here. Another thing that we can look at but haven't focused on greatly yet is which categories of websites are more local than others. This is just an idea of 100 websites that we tested, but we intend to scale this up, as Amrish mentioned, when we keep working on the projects in future. So the real question is, how close to the 50-50 vision are we, and how much work is left to do? As I mentioned earlier, there's a selection of 28 countries that were chosen by the Internet Society to start looking at the locality problem. And this is the locality of each of those countries. So as we can see, this green horizontal line that's in the graph is the 50% locality that we're trying to achieve by 2025. And you can see not many countries have achieved that. If we consider a percentage, 24% of the countries here have achieved this 50% locality. If we then look at that globally, this graph shows us the number of countries and the percentage of countries in the region that have achieved the 50% locality. And one of the questions that I usually get when I show this graph is, why were these countries selected? And these countries were selected to try and be representative of the global situation. As we can see here, 24% of countries have achieved a 50% locality. If we then consider the global traffic locality, also 24% of countries have achieved this 50-50 vision. And so that shows that the initial selection of countries was representative of the global situation. And now we can talk about next steps. So for us, we want to expand the testing methodology, for example, adding the latency and web scraping that I mentioned earlier. We've been testing for months and we will continue testing in order to find changes and patterns over time. Our results have also been published in a paper from the ANRW this year, as well as on the Pulse platform. As you can see in the corner here, there is a widget that shows the percentage of local content per country. So to summarize, there are benefits for local traffic. We've been measuring it over time with a focus on the 50-50 vision. We had a paper at the ANRW, and you can learn more about the 50-50 vision or check out the paper here. So thank you for listening. And yes, I'll now take any questions.
Thank you, James. Do we have a question for James? Yes, we have a question from Hank. So why aren't we using RIPE probes, which is available in every country to help measure things?
So the initial reason we're not using RIPE probes is because they are mainly used for trace route measurements, as far as I know. And the measurements we were doing have been more specific. So as I showed earlier, this set of lookups here, when we determine the website hosting, we do DNS lookups, whois lookups, and then we will do a GET request of the website in order to extract the headers. And this is something we also do for this geolocation step as well, because we extract geo hints from the returned information of the websites. And so in order to do these GET requests, we have been using the residential proxies. However, we've started testing the traceroute methodology using RIPE Atlas and global ping probes as well. So we haven't used them yet, but the intention is then to verify these results using the RIPE Atlas probes.
James. Yes, and we are using the RIPE Atlas probes for the trace route measurement, which is a continuity of this work.
Yes.
And we use the residential proxy specifically for HTTP requests, which unfortunately RIPE Atlas probes also cannot allow us to do.
Mm-hmm.
Great. Do we have more questions for James? I don't see any so far, but I wanted to, we have Joe. Joe, you have raised your hand. Would you want to intervene? Let me see if I can allow you to talk. There you go.
Oh, cool. So I'm speaking and you can hear me.
Yes, we can hear you.
Great. James, wonderful presentation. This is really neat work. I want to ask you a blank check question, which is, if now or in the near future, you could have some dimension of measurement or feature that would either help you extend this work or measure different things you're interested in, what might that be? So like, imagine being able to wave a wand and having it maybe a different orthogonal probe infrastructure, or I don't even know. So strange question, but hopefully a little interesting and creative.
Yeah, that's a good question. So I guess there's two ways to think of that. The first thing that popped into my mind was it would be good to have some ground truth so that we know whether the results we're getting currently are reflective of the actual situation. So as I mentioned, the fog of cloud, being able to verify that the results we're posting are what the providers see or think is happening from their end as well would be useful. And then in terms of future measurement infrastructures we could use, very good question.
you know,
I
like
suppose anything.
privacy preserving. I'm not sure if you're interested in that, or like, you know, you can also imagine there's these new network protocols that I think are scaring the crap out of some governments, like Mask, which is a one-hop Tor circuit, sort of like this is what Apple uses for private iCloud relay that hides your IP address from advertisers. But you know, to folks operating networks, this might appear to be, you know, something weird rather than just a new primitive that helps, you know, keep people somewhat private online. You know, and you know, that's the kind of thing where you have Apple Cloudflare in an end user's residential environment, and I just, that's less about domains and sites than sort of, I guess, actual real-time networks. So I'm talking too much.
Well, thank you for the comments there. That's an interesting. I certainly haven't thought about that yet. But yeah, the changes with protocols is definitely something we should be thinking about in future. And then another thing as well we haven't yet done is we've sort of been measuring content locality versus the traffic locality. We haven't applied traffic samples yet to our results. So having some traffic sampling measurement framework would also be super interesting in future as well.
Excellent. Yeah, I just wanted to also say that this work has been instrumental at ISOC. So we have already been using the results of this work in our advocacy work in different countries to try bring content closer to the end users so that it reduces latency and also reduces the reliance on usually expensive international capacity. So this is work we are continuing. We are looking forward to continuing to expand and also hopefully also write a paper about it.